Hey everybody, Mike here. Super excited to be with you on Sunday. I'm going to go over the NSX Advanced Load Balancer today, formerly known as Avi Networks Load Balancer. This is a super exciting addition to the VMware portfolio. VMware acquired them in, I think it was summer 2019, and it's just incredibly cool. It's a completely different way of load balancing than anything out there on the market today. So I think you guys will be excited. If you're a nerd like me, it's really cool. That said, let's get started. First, we're going to go into kind of an architectural overview of what the solution is, and then in the next video, I'll actually go through a live demo in my lab and kind of show you guys how it works in real time. I think you'll like it quite a bit, so let's get to it. The first thing you should know about the ALB is that it's built on a scale-out architecture. It accomplishes this by separating the data and control plane. And we'll get into a slide in a minute that kind of lays it out, but just know that there is a distinct difference in Avi or in the NSX ALB between the data plane and the control/management plane. That's a key component to how Avi can scale very large. Another item you should know is that Avi is very good at doing active-active load balancing. This might seem like a thing that should be kind of a prereq for any load balancing solution out there on the market today, but believe it or not, most solutions can't do this, and if they can do it, it's extremely messy. Avi makes it completely transparent, so it's super simple to achieve active-active load balancing, even if you're clueless when it comes to load balancing like I am. Now that said, one thing that it's also really cool about Avi is the visibility is incredible with Avi. Think of it like a time machine for your load balance traffic. If you've ever troubleshot anything on like an F5 or a Citrix or a Kemp, you're pretty much limited to, run a TCP dump while the issue is ongoing. With Avi, that's not the case. We can actually look back in time, and we can even look at client requests, and we can see them, see what happened, see where they were load balanced to. We can see if we were having issues with the load balancer or service engine as it's known in Avi, and we can basically do root cause analysis after the fact. This is incredibly powerful, and in my opinion, this is probably the biggest deal about Avi. That said, it can also load balance cloud, or in this case, public cloud solutions as well. So like Azure, AWS, GCP, etc. This is a really big deal because now we're talking about not only load balancing in your vCenter environment or your bare metal environment or for containers, but we can load balance with Avi or the NSX ALB across multiple physical locations, as well as public cloud again, and all from the same manager. In this case, it's called the Avi Controller, and we'll get to that in the drawing in a minute. And another benefit to this architecture is now that because we can load balance all of these disparate workload types, it's extremely flexible. So you can do just about anything you'd ever want to do from a load balancing standpoint with Avi. The other thing I want to mention that is probably not so obvious is that because VMware has branded it the NSX ALB, it's really confusing and you might be tempted to think that you need NSX to run it, but that's not true. You can actually run the NSX ALB or Avi load balancer completely independent of NSX. Now, I wouldn't be surprised if there's some integration coming in the future between the two, but for now, that is definitely the case. You can absolutely run ALB without NSX. In fact, when we get to my environment, I'm running straight vCenter with the NSX ALB or Avi. So I'll be showing you guys that in a minute. So moving on to talk about the architecture of Avi, this is where things get really cool. So we have the Avi controller that I mentioned before. This is your control/management plane. So this is where you'll be going into via the GUI or maybe via an API. And this is where you'll be making changes. So you'll be setting up pools, setting up virtual services or VIPs. You'll be setting up things like persistence or SSL profiles or WAF. Whatever the case is, you'll be doing all of that 100% from the Avi controller. Now this is deployed as a cluster of 3 for redundancy in production use cases, but you can absolutely deploy one in a POC or in your home lab. That's actually what I do. Now that said, a key factor of how Avi works is that there's actually no data plane traffic flowing through the controller. For that, there's actually what's called the service engine. So as you see here, the service engine is down here. This is basically a virtual appliance. This would be like a VM that sits in your vCenter environment. It can also, of course, in cloud use cases, it would sit in, for example, EC2, or it could also be on-prem as a bare metal server even. So there's different versions of the service engine, but in most cases, we're talking about just a virtual machine. Now this is the true data plane of the solution. So as you see here, we have this differentiation, this separation, in other words, between data plane and control plane. This is a really big deal. Basically, this means that this service engine is only responsible for forwarding traffic and carrying out the intent of the Avi controller. So when we make those configuration changes I mentioned earlier on the controller, it pushes those down to the service engine. Now that said, what if we wanted more than one service engine? Well, we can absolutely spin up another one without any issues. So say we're doing active-active, we could have a virtual service or a VIP active on this service engine as well as this service engine. So from a scale out standpoint, we can go very, very large and have very high throughput in our virtual environment. Another thing that's really cool about Avi is that it knows that if it loses a service engine, it needs to spin up another one to replace the one it lost, so that your load balancing capacity isn't affected negatively in the event of a failure. And the nice thing is, since the configuration is all stored on the controller, this again is all just pushed down to that new service engine, and there's no disruption in traffic at any point really. And think about also upgrades. If we wanted to upgrade a service engine, Avi is smart enough to move those virtual services or VIPs around while upgrading and rebooting service engines. And say the upgrade goes badly, well, you just kill the service engine, spin up a new one, and you're up and running. So it's extremely flexible, but that doesn't get to really the kind of the magic sauce which I kind of talked about, which was the analytics. So basically, these service engines have all of the traffic flowing through them, and they're reporting all of those headers and all of those logs up to the controller. Well, at the controller, we have this kind of bird's eye view of our load balancing environment, and we can look at really advanced analytics. So again, that's kind of our time machine for looking back and seeing what happened in our environment, what kind of operating systems are being used, where are our users accessing our services from, which servers are having issues, etc. This is something I can really explain best once we get to the lab portion of this series, so I'll just save it for then, but just take away from this video that analytics inside of Avi is extremely powerful, and to be honest, I think that's the most cool thing about Avi. So that said, in the next video, we'll go into how I have my lab set up, and then we'll get into a live demo of Avi in my lab. So I'm looking forward to it. I'll see you guys there. Oh, and since it's Sunday, I'm totally allowed to do this. So good.